All right, let's practice with this problem. Let's find the Tailor series for the function 1 over 1 minus x at x equals negative 2. So I already know what the series is if I ask for the Tailor series centered at x equals 0. That's the classic geometric series. But what happens when I want to center it at a different value, like negative 2? So I'm going to solve this problem in two ways, and you get to pick which one you like the best. So here is my answer, number 1. I'm just going to start taking derivatives. So I have my function f of x. That's 1 minus x to the negative first power. So I'll take a bunch of derivatives. The first derivative, if you take the derivative, you get 1 times 1 minus x to the negative 2. I got a positive 1 because I used the chain rule and got an extra negative sign from the derivative of 1 minus x. The second derivative would be 2 times 1 minus x to the negative 3. I pulled down the negative 2 in front, and then I got an extra negative sign again from the chain rule to get 2 times 1. The third derivative, 3 times 2 times 1. I'll write that as 3 factorial. 1 minus x to the negative 4. So I could see the pattern emerging. The kth derivative is k factorial. 1 minus x to the negative k plus 1 power. Okay. That allows me to write down my Tailor series. So my Tailor series is the sum, k going from 0 to infinity. This kth derivative, when I plug in x equals negative 2, so I have k factorial. If I plug in negative 2 for x, this becomes 3 to the negative k plus 1 power divided by k factorial times x minus negative 2 to the kth power. There, that's my Tailor series. If you'd like, you could simplify. This is the sum k going from 0 to infinity. The k factorials cancel. 3 to the negative power, that's really a division. So I'll write this as x plus 2 to the k power over 3 to the k plus 1 power. Okay, that's method 1. Let's compare method 2. So method 2 says, I already know the geometric series. I know the series expansion of 1 over 1 minus x. So I'm going to manipulate that to get my answer. Here's what I'm going to do. This is a little bit sneaky, so watch this. I'm going to write this as 1 over 3 minus x plus 2. You see what I did? I just took that expression, wrote it a little differently. You could see I get the same thing because I get 3 minus x minus 2. It's the same as 1 over 1 minus x. Then I'm going to multiply the top and the bottom by 1/3. So if I multiply the top and the bottom of this fraction by 1/3, I get 1/3 on top. I'm multiplying the bottom by 1/3. That gives me 1 minus x plus 2 over 3. In other words, this is 1/3 times 1 over 1 minus x plus 2 over 3. Now I'm going to use the geometric series I know for this. So the geometric series I know for that says I get 1/3 the sum, k going from 0 to infinity, of this thing to the kth power. So x plus 2 divided by 3 to the kth power. That's the same that I got up here. You could see that these two things actually gave me the same result. Okay, so I found the Tailor series. I did it two different ways. I got the same answer, luckily. Next, I'd like to know the radius of convergence for this series. Whenever you find a series, the next question to ask is, which values of x actually make this a valid series? Which values of x make this converge? So to find the radius of convergence r, I'm going to use the ratio test. So the ratio test asks me to look at some limit L. It's the limit as n goes to infinity. Here is my kth term. Actually, if you notice, this series and this series are the same. I just factored out a 1/3. So I could actually look at the kth term being this or the kth term being what you see here. I think I'm going to pick this one just because the plus 1 will be less annoying to deal with. So I'm going to look at the k plus first term. So that'd be x plus 2 over 3 to the k plus 1 power. And I'm going to divide by the kth term, x plus 2 over 3 to the kth power. If you simplify, I get the limit as n goes to infinity. This just simplifies to the absolute value of x plus 2 over 3. All the k's, limit as k goes to infinity, all the k's go away. So this has limit just absolute value of x plus 2 over 3. Now, if I'm using the ratio test and I want this series to converge, this has to be less than 1. So if I rewrite this equation, I need the absolute value of x minus 2, or x plus 2, to be less than 3. So I multiplied both equations by 3, and I got this. Now I know my interval of convergence. If you draw a number line, here's 0, -1, -2, -3, -4, and so on. It says that my value of x has to be a distance of 3 away from -2. So the center of my series is -2. I could be 3 away on either side of -2. So my interval of convergence is between -5 and 1. Now, that's the interval of convergence. So the radius of convergence, r, is equal to half the length, 3. All right, excellent.